Now, where do you find all these cyclic hexanes or cyclohexanes? We have all of these in the body. Cholesterol, vitamin D3, okay, is present everywhere. We must have cholesterols. Steroids, all of us, mammals, human beings, is omnipresent everywhere. Well, for cyclohexane, this is one of the most important member that you have to know very well among all the cycloalkanes, right? Cyclohexane is the one that you have to know the best. First of all, you have to know how to draw the shape, the structure, sawhorse, and of course the human projection. So here this adopts a chair conformation. Chair is the most stable because you can think of it as like a chair that you use to sunbathe on top of MBS hotel, like a chair, right? Comfortable. Sits here at the back, lying flat, enjoying the sunshine, the UV light. So the angle strain here is totally 0 because all the bond angles is 111.5, torsional strain 0, adjacent CH bonds all staggered, in out, and steric strain again 0. Perfect. The chair conformation of cyclohexane is actually influenced by the total energy of the system because it's the most stable form, and that's why it adopts the chair conformation. Now in glucose is actually having a formula of C6H12O6. So there's 5 hydroxy groups in the glucose molecule, and how do they adopt their positions? You notice that, right? OH here points to the equatorial positions, equatorial. For cycloalkanes, in particular cyclohexane, we have got 2 kinds of positions for substituents. One we call axial. The bonds are pointing at right angle to the plane. This is plane, right? So it's right angle, perpendicular. And the other one is equatorial position, so it's going out of the plane. Let me just bring our model here. Now, so you see this example. This is a toy, right? A model that you see something like the lecture notes, right? Hope you can see it. So all these bonds that I'm pointing to right now, they are what? Equatorial, equator. And these bonds here, they are axial. Do you see? Axial positions. So there are 2 kinds. Now for each carbon, there is 1 axial and 1 equatorial positions. You see? Each carbon is the joints, right? 1 axial, 1 equatorial. 1 axial, 1 equatorial. Okay? So this is the picture that we see that if you look at the cyclohexane from the top here, this is what you observe, just like what you see in the lecture notes. Okay, maybe here. Can you see? Alright. Something very important is knowing how to draw the conformer of cyclohexane, especially the chair conformer. So now everybody please pick up the pen, okay? Pick up the pen, right? Ready? We're going to have a drawing class right now. So here we go. Step 1, draw 2 parallel lines of the same length this way. Imagine, right, it's like a parallelogram that you're trying to draw. Next, about 2/3 from the left hand side, okay, this point here, and 1/4 from the top. You put a dot here first, a point. Okay, this doesn't represent a methane, okay, but just a point. Likewise, from the bottom side, about 2/3 from the right and 1/4 from the bottom, put a dot here, okay. Then now you connect them. Connect the dot, okay. Connect the dot, okay. I'm using a pen, so it's rather bad, okay. This is lousy, don't do that. Let me try it quicker. You connect the dot, but you don't do it when you're having chicken pox. Again, this is poor because I see a line coming out. I can do much better. You know this, right? In class. Ugh. A bit better, but still can be improved. You can try using an eraser and take it out. So this is how you draw this. 1, 2, 3, 4, 5, 6. You see, no crossing. 1, 2, 3, 4, 5, 6. This pad is misbehaving. Okay, anyhow, let's presume that, right, this is a good structure. So how do we put the axial and equatorial positions for all the carbons? You see that, right? You got 1, 2, 3. They are higher than the rest, right? 1, 2, 3, 4, 5, 6 carbons. These 3 here that I'm pointing to, they are higher than the rest because they are going up. So for the one that's going up, you put a stroke from the top, okay? Just one stroke, 1. So these are the axial positions for these carbons. Now for the 3 that's lower in the plane, you put the stroke down. Okay. Then next, for the equatorial positions, let me change the color. Blue. It's a nice band from UK. Alright, for this carbon here, how do you know where does it point to? Equatorial. You watch out for this line, okay? It should be parallel. This line here goes this way, right? So you draw it. Just sing a song with me. Up, down, up, then down. Okay? For the bottom one is down, up, down, up. Okay? Easy. Now for the medial tool, it's a bit tricky. We know it's going to point sideways, but is it left or to the right? So which one do you follow? Notice these parallel lines. Okay, you follow the same direction. So should turn to the left a bit for this carbon, to the right. Okay, voila. C'est facile. Alright, not too difficult. Try and practice. We'll go through this in class again. Or you can follow this guideline and practice as well, but I prefer the previous one. Now for the chair conformation of cyclohexane, I could know that, right, it can undergo what we call a ring flip. Now when you do a ring flip, it doesn't mean like, you flip. You don't flip, okay, like flipping burgers, no, you don't flip, okay. When we talk about the ring flip in cyclohexane, what we mean is, right, this is cyclohexane. The flip means it's inside out flip. Now imagine my shirt, right, I can't take it out right now because I'm just wearing one layer. Or a plastic bag. You pull it and take out, inside out, you change it. This is something like a ring flip in cyclohexane. So let me demo for you. Okay, you see that, right? We have got one substituent here, which is in the axial positions. So let me try to do a ring flip for you. Okay, take note, this is no magic. Ta-da! Do you see that? Do you see that? What happens? The substituent become equatorial. From just now it was axial, then now equatorial. You see? I didn't bluff you. I didn't do this and then do some funny motion to distract and put it there. No, okay? Watch it one more time. Okay? Right here. Okay? And ring flip. God, you heard that? I broke it. Oh, damage of $20. Oh, goodness. Alright. Well captured on the screen here. Let me redo this again.